First, consider the case in which the coefficient on P1 is greater than 0. In this case, the expected payoff for player 1 is strictly increasing in P1, and so player 1 will maximize his expected payoff by setting P1 equals to 1. This means that player 1 chooses H with certainty as long as P2 is greater than 1/2. Now, the best response of player 1, denoted by BR1 of P2, is the set of possible P1 that maximizes the expected payoff of player 1 for a given value of P2. The best response of player 1 is shown on the graph where we take P1 on the vertical axis and P2 on the horizontal axis. The graph here shows that the best response correspondence of player 1 is 1 as long as the player 2 chooses H with a probability greater than 1/2. Now, consider the case in which the coefficient on P1 is exactly equal to 0, such that P2 is exactly equal to 1/2. In this case, it does not matter what the value of P1 is, since the expected payoff of player 1 does not change by altering P1. Any mixed strategy is a best response for player 1 when P2 is exactly equal to 1/2. A best response correspondence of player 1 can be any value between 0 and 1, as long as player 2 chooses H with probability of 1/2. BR1 of P2 is therefore the vertical line shown here. Lastly, we consider the case in which the coefficient on P1 is negative. And this is the case when P2 is less than 1/2. In this case, the expected payoff of player 1 is strictly decreasing in P1, and so player 1 chooses H with probability of 0 to maximize his expected payoff. Therefore, best response correspondence of player 1 is 0 as long as P2 is less than 1/2. If player 2 chooses H with probability greater than 1/2, then player 1 chooses H with certainty. If player 2 chooses H with probability exactly 1/2, then player 1 chooses H with any probability. If player 2 chooses H with probability less than 1/2, then player 1 never chooses H. Similarly, we can derive the best response correspondence of player 2, and it is shown on the graph here. Since the payoff structure is symmetric across the two players, the best response of player 2 is exactly the same as the best response of player 1. We now combine the two graphs together to figure out what the mixed strategy Nash equilibria of this game. A Nash equilibrium is a strategy profile in which every player best responding to each other. And so the intersection of the best response correspondences exactly picks up all Nash equilibria of the game. This graph here shows that the best response correspondences intersects only at one point in which both players choose H with a probability of 1/2. And so this game has a unique mixed strategy Nash equilibrium where P1 and P2 are both 1/2. Let's take a look at another example. Example 2 is more complex than example 1 in that player 2 has more strategies. To solve this problem in a simple manner, it is important to realize that strategy C is strictly dominated by a mixed strategy that mixes strategy A and B. To see this, consider a mixed strategy where player 2 mixes A and B with probability 1/2. You can see that the expected payoff under the mixed strategy is strictly larger than the payoff with strategy C, whatever the strategy of player 1 is. Therefore, strategy C can be eliminated from the game, and we consider a smaller game that does not contain C. We can again solve for mixed strategy equilibria following exactly the same way as we did for example 1. The best response correspondences in this case, however, crosses 3 times. The best response correspondences crosses once when P1 and P2 are both 0. That is, both players play strategy B with certainty. The best response correspondences also crosses when P1 and P2 are both 1/5. Finally, the best response correspondences crosses when P1 and P2 are both 1. That is, both players play strategy A with certainty.